Hey guys, this is Harold L.R. Watkins back with another video. In this video, I will be demonstrating my AutoSec Local AI, a private assistant designed for automotive diagnostic, vehicle testing, and cybersecurity analysis. It runs directly on my computer instead of sending information to a cloud service. My goal was to make its responses fast enough for practical daily use. This computer that I'm using has two NVIDIA T600 graphics cards with 4 GB of memory each. The screen confirms that both cards were detected and GPU offload is supported. To keep the comparison fair, I use the same Llama 3.23 billion parameter model, the same question, a temperature of 0, and the same response limit for both tests. So here you can see that my computer is running the NVIDIA T600. I also have an option to select CPU baseline or GPU accelerated. I'm going to start with CPU baseline. I'm going to load my model, which is here. And because it takes time, I'm going to begin to run it. Okay. I first measured the model using only the normal processor or CPU. In my final CPU test, the response took 19.915 seconds and produced 7.82 tokens per second. A token is a small piece of text, so a higher token rate means the answer is being written faster. Next, I installed NVIDIA um, CUDA, that's how you pronounce it, CUDA 12.8 in its Visual Studio 2022 integration. CUDA allows the application to send artificial intelligence calculations to the graphics card. I rebuilt the local model library with CUDA support, enable flash attention, and I added the setting NGPU layers um, which equals -1, which requests full GPU offload. I also added control CPU and GPU profiles. I fixed benchmarks, first response timing, total timing, and token per second, and CSV export. These additions makes the measurements repeatable and easy to verify. All right, so I just want to show you my last test that I documented here. It's going to be a new test after this, but this is how I track the comparison. So now that we ran the CPU version, we now are going to run the GPU version. So I'm going to load this, and the GPU actually runs a little bit faster, or I should say a lot faster. All right, and then we're going to run this, let that run. Okay, with GPU acceleration, the same test took in my previous test. It took 6.337 seconds and produced 40.367 tokens per second. Total res total response time improved by 68.18%, making the response about 3.14 times faster overall. Throughput increased by 416.2%, which is about 5.16 times the CPU rate. The first part of the answer also appeared about 13% sooner. GPU model loading took slightly longer because the graphics system needed time to start. However, Once loaded, the model responded substantially faster. And so with these new readings, I'm going to run this export. I'm actually going to save it here. This is going to be 4 because I ran it a few times. And then I'm going to grab it from over here. Let me find where it's at. Should be here. Okay, I found it. So, all right, got it. Yeah, you can see I ran it a few times. So I'm gonna get rid of all the noise and just bring this up here like that. These are my new readings. Um, okay, so what failed is the next thought. So the process did not work on the first attempt. The original library supported only the CPU, and my first rebuild selected a Visual Studio version that CUDA 12.8 did not support. I corrected that by using the Visual Studio 2022 tools and CUDA integration. I also tried a larger 13 billion parameter model, but it could not fit safely into the available graphics memory. So I selected the 3 billion parameter model that matched the hardware and full GPU offload worked successfully. In summary, GPU acceleration reduced response time by about 68% and increased writing speed by more than 5 times. AutoSec Local AI is now fast enough to serve as a practical private assistant for automotive diagnostics, testing, and cybersecurity analysis. Thank you for watching.